Welcome to hypothesis testing. We're going to be going over the 5 steps to conducting a hypothesis test. Step number 1, state the null and the alternative. The H0 in this case is the null, H1 is the alternative. And they're written in one of 3 ways. The first way is the null is the mean of 1 is equal to the mean of 2. The mu is in this case the mean. The alternative, for H1, is the mean of 1 is not equal to the mean of 2. This would be a two-tailed test. Another way of writing the null and the alternative would be the mean of 1 is less than or equal to the mean of 2. The alternative would be the mean of 1 is greater than the mean of 2. The third way of writing them, the null, the mean of 1 is greater than or equal to the mean of 2, and the alternative would be the mean of 1 is less than the mean of 2. Okay. As you'll notice, there's a couple of patterns with this first step. First of all, every null has the equal sign, be it the actual equal sign, or less than or equal to, or greater than or equal to. The alternatives do not have an equal sign in them, be it not equal, greater than, or less than. Also note that when it's equal to each other, as in this case, equal to or not equal to, it's a two-tailed test. An easy way to remember it is to think of it as two alligators sunning themselves or swimming in the pond. They have two tails. These are alligators opening their mouths, and only one alligator means one tail. Okay. Also, I've noted a trick here. The question asked will give you the information needed. Do not overthink it. Oftentimes I find students trying to manipulate the question or trying to manipulate the words to create what they believe is the null or the alternative. The question is going to give you one of these 6 options, whether it be the null or the alternative. From that question, you can just assume that it's going to be the opposite based on one of these 3. And this will make a little more sense once we get into the actual questions and a real example. Step number 2, select level of significance and test statistic. So level of significance are usually found, 99%, 95%, and 99%. And we're going to be looking for P critical values, Z critical values, and T critical values. And these are found in various different ways. The easiest one in my mind is the P critical value, which is these numbers based off of the significance level. For your Z and T tests, or T values, you're actually going to be having to look up a value based on the Z scores and T scores as well. Okay. So step number 3, formulate decision. So for P values, we're assuming that it's at the 95% confidence interval, or 0.05. If the P value is greater than 0.05, you fail to reject the null hypothesis. If the p-value is less than 0.05, you reject the null hypothesis. Okay. Meaning, for p-values, you want a very low number. The lower, the better, which is actually the opposite of t and z values. Now, in this example, I've given just the t values because t values are more often given than z values, but the same goes for both. If the t value is greater than the critical value, then you reject the null. This is opposite of your p-value. T-value, if the t-value is less than the critical value, you fail to reject the null. Meaning, with t-tests or t-values and z-values, you want a high score. So just to recap, p-values, low score. T-tests and z-tests, if you're looking at the critical values from your t tables and z tables, you want a very high number. Low number, high number. Number 4, run the test, get the results, make decision based on number 3. And number 5, analyze the results, give insight to the problem. Now, as an added bonus, let me kind of zoom in here. For the z values, I'm giving you the critical values already in place, mainly because they are pretty redundant and fairly standardized, I can just give you those numbers, and here they are. So hopefully that will help you in your studies and as you go through the problems when they ask for a z-value, here they are based on the confidence interval. Okay. Next video, we're going to be looking at the z-test.